Hello, Williams class. Your arithmetic today is as follows. 2 times 7. What is 24 shared into 3? What is 999 as a Roman numeral? What number is next in the sequence? 4, 7, 10, 13. 4 times 9. 72 divided by 8. What is 2 kilometers in meters? 5,843 plus 3,232, 9,875, take away 4,555. 42 divided by 6. Here are your answers. 2 times 7 equals 14. What is 24 shared into 3? 8. What is 999 as a Roman numeral? CMXCIX. What number is next in the sequence? 4, 7, 10, 13, 16. 4 times 9 equals 36. 72 divided by 8 equals 12. What is 2 kilometers in meters? 2,000 meters. 5,843 plus 3,232 equals 9,075. 9,875 take away 4,555 equals 5,320. 42 divided by 6 equals 7. Our learning objective for today is, can I show equivalent fractions using diagrams? So by the end of this lesson, you will be able to use pictures to show equal fractions. Quick recap, what is the shaded fraction? Use the fraction wall to find 3 more fractions that are equivalent. Have a go at answering that for me. So you have a quarter, which is equivalent to 2/8, which is equivalent to 3/12, which is equivalent to 4/16. Because they are the exact same size as each other, no matter how many times they have been split. So I would like for you to find me 3 more fractions that are equivalent to all of these fractions that have already been shaded. I will give you an example, actually. While I'm shading it in, you can tell me what fraction you think I am about to write about. This is 1/2. And I would say 1/2 is equivalent to, I'm going to use this. So I'm just checking to see which other bar shows the fraction in the same, that has the same size, and they are the same size because both of those fractions stop on the same at the same time. So this fraction would be 3 I've shaded out of how many? 6. So 3/6. So those are equivalent fractions. That's an equivalent fraction pair. So let's see if you can find maybe 2 more like that for me. Use the diagram to complete the fraction. So we have here 2 or 1/2, because 1, half of that bar has been shaded in. What is the equivalent of that? How many bars, or not bars, but how many parts of that bar have I shaded in the second bar? So look, this is a 1/2. What is this? We know that it has 12 parts already, so it's going to be something out of 12. All you have to do is count the number of parts. 1, 2, 3, 4, 5, and 6. So that would be 6 out of 12. Similarly over here, 2/3, which is this fraction over here, I'll label it for you to see because 2 out of 3 parts have been shaded in. But how many parts out of 12 have been shaded in the second bar? 1, 2, 3, 4, 5, 6, 7, and 8. So that fraction then is 8/12, because out of 12 parts, you have shaded 8 of those in. I would like for you to sketch your own bar diagrams to complete the fractions. You have 1/2, so you have to draw a bar that is showing an equivalent fraction to a 1/2, a 1/3, and 3/4. And a hint there that they've given you, or that I've given you, is that you know how many parts to divide your bars into. So for the first diagram, you're going to divide it into 6 parts. You're going to divide your second bar into 12 parts, and your third part into, or your third bar into 8 parts. Have a go at sketching your own bar diagrams for me. Off you go. Now let's have a go at doing this together. So I am just going to click on a color. We'll go for this one. So I'm going to draw my bar just like this. I really wish I had a ruler, boys and girls, but it is what it is. So 6 parts. 1, 2, 3, 4. So let me just check if I've divided into 6 parts like I meant to. 1, 2, 3, 4, 5, 6. Now, I have to show a half shaded in. So what I have to do is look at the denominator and halve it. So what's 6 divided by 2? 3. So how many parts do I have to shade in? 3. So I've got 1, 2, and 3. Now this is just one way of drawing your bars for your equivalent fractions. If you found another way that works for you, please use that. That's absolutely fine. For your second diagram, you have to draw your bar that has been divided into 12 parts. So just to be safe, I'm going to, oh goodness, it'll do. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll split it there. So this should be divided into 12 parts. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, I can't say this enough times, boys and girls. I wish I had a ruler. I think I do, actually. I might use a ruler next time. But please make sure you're using a ruler at home. So you have 12 parts here, as the question tells us. And we need to show this bar as being shaded in by a third, okay? When you have to show it by a third, look at the denominator for your first fraction. It's 3. That's what you have to divide 12 by. 12 divided by 3. So how many 3s go into 12? 4. So that means that you shade in 4 parts of your bar. A nice little trick there to show you. So that means I didn't even write down the equivalent fractions. Let me just write down the equivalent fractions really quick. So the equivalent fraction here was 3/6. The equivalent fraction here is 4/12 because you just put the numerator on top of the fraction that has been half completed for us. Now your next bar has to be divided into 8 parts. So let's do that like so. 1, 2, 3, 4, 5, 6. That should be divided into 8 parts. Actually, hang on, I think I need to do it one more time. 1, 2, 3, 4, 5, 6, 7, 8. Fantastic. So that's been split into 8, as our question tells us. Now we have to shade in 3/4 of that shape. Now here's the trick. You look at the answer that you need. So you do want something out of 8 as your final fraction. Okay, look at the fraction that you're starting with. What you have to do is divide 8 by 4. And that answer you multiply by 3. That's just a little formula that you have to use when calculating equivalent fractions. Divide by the bottom number and multiply by the top number. It's a trick that you may have to learn. So start off by dividing by the bottom number, which is 4. How many 4s go into 8? 2. Don't stop there. You multiply by the numerator, the top number, which is 3. 2 times 3, 6. So that means our answer at the end is 6 out of 8. So that means we have to shade in 6 parts of our bar. 1, 2, 3, 4, 5, 6. And you'll have seen that you have found an equivalent fraction. 3/4 is the same as 6/8. So that can be either 3/4, it could be labeled as either 3/4 or 6/8. They're both equivalent fractions. They are the same. Now, to make sure that we don't forget our trick, I'm going to write it up here for you to have on the board as you're doing your work, if you would like to. I'm going to write when calculating equivalent fractions and I'll do number 1. Divide by the, no, not numerator. I always make that mistake. That's okay, we all make mistakes. Divide by the denominator. And then I hope some of you are already saying what we should do as the second step. Multiply by the numerator. I'll give you an example. If we have 6/12 and we want to work out an equivalent fraction, and we have the denominator already given to us, divide by the bottom number, so 24 divided by 12, what is that? How many 12s go into 24? 2. And then you multiply by the top number. So you divide by the bottom, multiply by the top. So you take 2, which is our answer that we've just gotten, and you multiply it by the numerator, which is 6. 2 times 6? 12. So that is the numerator for our equivalent fraction that we have just created. I hope that makes a bit more sense now that I've explained that a little bit further. Okay, so let's try and find equivalent fractions in this fraction bar model. So we have 1/3 to start us off. Now we need to find 1/3 first of all. I'm just going to draw a line because I find that the line really helps me. And then what you're going to do is find the fraction that is equivalent to 1/3. Now we are given denominators. We're given the denominator 6, 12, and 24. So that tells you what part of the model to look at. So if we take our first fraction that we have to complete, it is over 6. So what you have to do is go to the bar model and go to the part where the denominator is 6, which is here. Can you see here? It's over 6. And all you have to see is check how many parts of a 6 make up 1/3. So 1/3 is this long, okay? This is our 1/3. This is how long it is. So you draw a line to where it ends and go down, and look, the 6 stops there. So how many parts of, or how many 1/6 fractions do you need to make up 1/3? You need 1 here, you need another here. So in total, you need 2 of them. So that would be 2 out of 6. Let's try with creating a fraction that has a denominator of 12. I'm going to move my voice. You're going to find the 12 bar, which is here because all the denominators here are over 12. Then follow the pattern. So you follow where the line for the 1/3 stops. Keep going down. So we've done a 6th already. Keep going down until you hit the bar model. Red wasn't the best choice for color of pen, but you stop there. And now you just count how many fractions or how many 1/12 you've used in order to then make up a bar that is the same size as the 1/3. So that's 1/12, that's another 12th, so that's 2/12, 3/12, and 4/12. So you've had to use 4 of those. How many do you think you'd have to use for 24? To have a denominator of 24, how many parts would you then use? And what would be your numerator? If you said 8, you would have been correct. What is the pattern that you notice? The pattern I notice here is the denominators are getting bigger by multiplying by 2 each time. Let me show you what I mean. What's 3 times 2? 6. What's 6 times 2? 12. What's 12 times 2? 24. Now, what have I just told you about the relationship between numerators and denominators? I told you that what you do to the bottom, you do to the top. So if the bottom numbers, the denominators, have been times by 2, what's going to happen to the top? They are also going to be multiplied by 2 each and every time. Let's test this theory of mine. What's 1 times 2? Oh, it's 2. What's 2 times 2? 4. And what's 4 times 2? 8. So that just goes to show then that what you do to the bottom, you do to the top as well. True or false? 1/6 is the same as 2/12. Is that true or false? The next question, if the denominator in a fraction increases from 4 to 8, we must add 4 to the numerator also to keep the value the same. Is that true or false? C, if the numerator in a fraction decreases from 20 to 10, we must divide the denominator by 2 as well to keep the value the same. Is that true or false? And then D, 6/7, is that the same as 18 over 21? And then E, is 9 over 36 the same as 3 over 30? Equivalent fractions time. We are going to complete these equivalent fractions. So have a go at answering these questions and then we will go through the answers together. Let's start going through some of these answers. Complete the equivalent fractions. Now A, we have 1 over 5. We need to make an equivalent fraction. What we've seen happen with the denominator, to go from 5 to 10, we've multiplied by 2. So you do 5 times 2, which is 10. So you do the same to the top. 1 times 2, 2. So your answer is 2/10. B, 4 over 5 is the same as or equivalent to 8 over 10. C, 3 over 10 is equivalent to 6 over 20. D, 3 over 10 is equivalent to 9 over 30. E, different one. 6 over 8 is the same as 3 over 4. Now, the way to work this out is figure out how you get from 6 to 3. You don't multiply anything this time because the number is getting smaller. So the opposite of multiplication is division. So you're dividing the number. And you're dividing here 6 by 2 to get 3. So you do the same to the bottom. What's 8 divided by 2? 4. So that would be 3 over 4. 8 over 12 then would be 2 over 3. G, 8 over 12 is the same as 2 over 3. H, 2 over what is the same as 10 over 25? It would be 2/5. 2 over 5 is the same as 5 over 25. 2 over 5 is the same as 10 over 25. And lastly, 1 over what is equivalent to 4 over 28? It would be 1 over 7 is equal to 4 over 28. Question number 2. Find 3 ways to make the fraction equivalent. So you're trying to work out and create equivalent fractions here. Off you go. So here are the fractions that I have made, but you may well have made different ones. So what I've done here is I looked at A, and I saw that to get from 2 to 4, I had to multiply by 2. So what I did is I just created a fraction on my own. I thought, let me just put the number in as 6. But then what I remembered to do is, if I multiply the top by 2, I have to multiply 6 by 2 as well, and I got 12. So I found 2 equivalent fractions there. 2 over 6 is equal to 4 over 12. Similarly, I found that 1 over 7 is equivalent to 4 over 28, and 2 over 3 is equivalent to 6 over 9. Question number 3. Eva and Ron have a baguette each. The baguettes are the same size. Eva cuts her baguette into 8 equal pieces. And Ron says, 3 of my equal pieces are equal to 6 of Eva's. How many equal pieces has Ron cut his baguette into? I would like for you to post your answer on Tapestry and I will have a look. That is all for your maths lesson, boys and girls. It was to show equivalent fractions using diagrams. I hope that that was useful and helpful, and I hope that you've gotten a little bit more confident at calculating and working with fractions in general. Take care, stay safe, make sure to remember that we have Tapestry and our lives to talk about these questions in more detail as well, so do not worry. I'll see you very soon.